Good Friday evening. Well, I took the meter out of that little Signal Corp meter there, and I'm going to give you some close-up looks of it. Yeah, that don't sound right, does it? Close-up looks. Well, you know what I mean. Anyhow, I had to break the glass, and I'll show you. It was soldered in. You know how like they do soldering on stained glass windows and stuff like that? Well, that's how that was. And I took my soldering gun and tried to unsolder it. But when you heat up one part, that cools down time you get down here. Obviously, these things must be dipped in flowing solder like that, you know, at one shot. Anyways, I didn't try to adjust the pointer yet, but the needle does move. I don't smell anything burnt in there. And on the back of the meter, it says sealed. It's in yellow lettering right above the handwritten full-scale 250 microamps. I copied that and wrote it on the back. Sealed, do not open. There was no way you can get in. The glass covered the entire circle. In other words, the glass went all the way around. So I had to break it. I could not get it out. I took a single-edge razor blade and went between the glass, and I kept going around and around and around with it. And I just couldn't do anything. And then I was taking my little screwdriver, and the very fine, my little Exolite, which is one of the best little screwdrivers I've got, flat blade, and try to dig in there. And what I was doing is making little tiny hairline cracks in the glass. So I held this over the trash can, turned it upside down, and tapped on it. And that glass is very hard to get out. It was really in there, and I had to be very careful with a hooked needle nose, holding this thing upside down like this, and reaching underneath, tapping the glass to keep the glass from going into the movement. I got it all out. I cleaned it all out. I used masking tape and Scotch tape to pick up any small fragments of glass, and I'm in the process of taking some large masking tape and going over the bench, because a couple of little pieces flew over there and you can get cut on the pieces of glass. So this bezel was on here like that. I had to take the whole thing out. One of my viewers said just release 2 screws and you can swivel it out like that, and you can get at the adjustment. Well, you can swivel it out, but I had to remove one nut and bolt on this side, but it was all covered with glass, so I still couldn't get in there. I didn't try adjusting this yet. So if this meter performs properly after I set it down to 0, if I can do that, somehow I don't think it will, then I'll have to use a piece of plexiglass, take some silicone and put it around here, and put a piece of plexiglass in here and drill 3 holes for the screws to come in. But going into the meter, I got the meter put off to the side right now, I'm not going to be able to get the nuts back in there because I can't reach in there. You know, getting them back, see where my thumb is? That's one of them. So trying to get the nut back in there again is going to be just about impossible. So if the meter is definitely no good, I might as well scrap the rest of this and take this thing all apart and use the case for something else. Okay. Now, I know I'm in camera. Maybe I can adjust that. This is the finest screwdriver I've got. Well, I've got jeweler screwdrivers too, but this is like a less than an 1/8 inch. Might need an eye lope. I might need an eye lope. I can't even see that. No, not even turning it. There is a slot in there, but as big as this, as small as this screwdriver is, it's too big. Sometimes you can move it with these ears down here. Oh boy, what do they do? Glue that in there? Usually you can move that little fork. I don't know if you can see that or not. Probably not. I have no idea, but there's a little fork in there. That's not moving. I have to pick this up. I'm left-handed. I'm trying to work on an angle so you can see it. I'll come back on this video. I got to find a screwdriver. Okay, even with the oscilloscope probe adjuster, it fits into the slot. It's plastic, but it's got a metal thing. I can't turn that. But upon close examination with my eye lope, there was a nut right here. So what I think you have to do is to put a wrench on that. I have a small set of wrenches, Craftsman ignition point wrenches. They're really, really small. I hope I got one that'll fit that nut. I think what that is locked down. I'm going to do that off camera and get this to 0. Then I will take and run this meter and see what voltages I get out of it, put the meter out of the case and just run it on clip leads. Well, all my Craftsman ignition points set. Not every one of them's too big. I mean, as tiny as this is, it's too big. So I have one other option. I have a set of small sockets, precision socket with individual handles on them. I'll try that. I bought this set in Sears back around the early 70s. Back when I had my 63 Ford Galaxy, and I bought this whole ignition point set here. All Craftsman, American made back then. Well, this is 1/8. That's the biggest one in here, and it's too small. And I don't have anything else. The ignition set wrench wouldn't sit down in here to get a good bite on it. I really need something like this. There's no way I can put a pair of pliers in there and do it. I'll ruin it because I just can't see. I have my reading glasses and I have to use my eye lope, and I can't hold that and do this all at once. And I tried other vision aids and they're just not working. So the other option is I could bend this needle to get it to sit on 0. That's not the way I want to do it, but because this thing reads almost 40 volts on the 40 volt scale with a 9-volt battery, means that this may not be the meter entirely, because setting that on 0 isn't going to correct that big error. It's got to be some resistors off somewhere. Or if there's any resistant wire in here that is affected, like this is 200 and can't even read my writing. 250, I guess. 250 microamps full scale. So I imagine if the winding is burnt, it's not going to give you an accurate reading. So let me play around with this off camera. Well, failure. the needle is frozen up no matter what I did. I had to take my hook nose, needle nose here, and I did it under an eye lope. I was very careful not to hit this, and then I took my precision screwdriver and adjusted it, but then it like jumped and then it jammed, and now nothing. It's no good. Well, I had a hell of a time getting this thing apart. I got a good strong magnet out of it, but boy, what a job taking that screws out of that thing. So, got a good magnet. Got a dial scale for whatever use that'll be. So, anyways, when it comes to precision stuff, I'm a total failure. But the meter was shot anyway, so not going to zero really had not much to do with it other than the exact reading. I mean, it would have read a little high, but not 35 or almost 40 volts on the 40 volt scale using a 9-volt battery. I mean, so there's definitely problems here. So what I'm going to do is to put this in the recycle. I can't use it for anything. Save this and put these in the recycle, and that's it. So I'm glad I didn't try to force it with my oscilloscope probe screwdriver, or I would have ruined it, because I couldn't turn it with these until I loosened that nut. And when I loosened the nut just a little bit, I got it loose just a little bit, and the thing just, when I turned the screw, it just like jumped, probably went off of the pivots. Hey, give it a try. The case is good for something, and the resistors, if I need a precision resistor, like maybe in a tube tester or something along the way, you never know. We'll just take out this board, which I'll probably have to remove a lot of these resistors in order to get the screws out, and save the case. Something can be put in there. I don't know what. I got myself some parts here. I got some precision resistors. Got a potentiometer and the switch. Not much else I can use it for. I could probably build something in that. Whether I can use this face or not is another story. But the case, I can build something in. You know, like, well, I don't have the eyesight to build an ESR meter, similar to Alan there, the Tektronix technician, who built one a number of years ago. But I don't have the meter for it anyways. But that is a thought. And using this board could be, but I don't have the, I can't work with that small stuff. I have to have point-to-point wiring. I can't work with ICs and stuff like that. I just don't have the eyesight for it. I have all I can do to work on what I'm doing now. But anyways, I'm taking out all these coils and stuff here, and I just got a bolt that goes right through here, and you take the nuts off and the things come right out. Precision resistors can always be used for something. You never know, I might run into something that would be the right resistance for a precision piece of equipment, such as a tube tester or something. Speaking of which, I want to briefly touch on the tube tester. I got it calibrated, and I had to go into my junk box and make up a 5.1 thousand ohm resistor. I had two 10,000s in parallel. That gave me 5,400. The best I can do. Now I got that in, I calibrated, and it seems to work quite well. But I'm very confused on the setup chart here, and I want to show you that. So the only book I have for the tube tester is one I downloaded. I have a book coming with a tube setup chart in it on eBay from Coltronics. I haven't heard that name in many, many years. I used to get stuff from them on a Sylvania tube tester I had. I think it was a Model 140. One of my first good emission tube testers. And I used to get stuff from Coltronics all the time. So I've got a book coming, and maybe it'll explain the strange numbering system that I'm going to show you on the tube tester. Let me get this thing off the bench here, and I'll show you. My videos are getting to be too damn long. Alright, I downloaded this. And I did the calibration, and the operating instructions are here. But I can't understand this setting now. I went to test the 12SQ7, which showed short on my other two tube testers, but I couldn't test it in here. If you take a look, 12SQ7, right at the bottom of the scale here, it says test 1-2. Now I would imagine that would mean (12SQ7) test 1-2, 12SQ7-3, test 3. I have no idea what the hell that means. Now, over here it says on the 12SQ7, right here where my finger is, it says A is 1-1. There is no 1-1. There's 1, 2, 3, and 4. There is no 1-1. So what does that mean? You know? That doesn't tell you in the book. I'm hoping that book that I'm getting from Coltronics from eBay, which is, like I say, it's a 1977 book on this tester, a setup chart, I believe. It's not an instruction book, it's a setup chart. Maybe it'll explain why. How am I supposed to test the tube? What the hell does 1-2 mean? What the hell does 1-1 mean on A? There is no 1-1. That's the only A circuit that I see. Unless it has something to do with this. But I don't know. Maybe you throw that switch and that's the other one. You got one here and maybe one here. And then 12.6 is the filament. And then C, it says 22 to 30. I mean 22 to 50. See that right there? Does that mean that it's good between 22 and 50? I don't know. My other two tube testers aren't that way. And they're both basically emission testers. So this book doesn't tell me everything. It doesn't mention anything about that at all. It tells you how to use it, and I read this over several times, and it mentions nothing about that 1-1 and test 1 and 2 and test 3. It tells me nothing in that book. Okay, so that concludes this video. I got to get some Phillips screws and put it in. I got this working very well. I got to get a knob for this. I don't know where I'm going to get one, but I always like my things looking good. Speaking of knobs, on the Navy oscilloscope, I emailed Fair Radio Sales, and they're going to send me 2 knobs, and I've asked them, this was cracked. This is still working, but it's got a crack in it, and it could break, so I got 2 knobs at $2.50 a piece. They have a minimum of $10, and the bezel screw they want $1 for. They're not very cheap, and I asked for the connectors for the back of the plug-in, the male and female, so they gave me a price of $6, but that's each, the both, so that's $12. I'm not going to spend that money. That's crazy. Because I have to rip this out, and I'm going to destroy the connector because it's frozen in the back, because I got some loose connections, as I mentioned in the video earlier. When I touch it very gently in there, the trace goes all over. So there's something loose in the plug-in, and unless I can get this plug-in to come out, because you loosen this, it don't come out, it's frozen in the back on that connector, I'm going to have to destroy it. So I won't be able to fix that instability until then. So I got 2 of these knobs coming, and a bezel screw. The whole thing is $14, $4 for shipping, and I didn't meet the minimum, so they're going to hit me $10 for that. There was nothing else. I didn't need the other knobs, and they have red knobs at $2.50 a piece. I couldn't see replacing them when I put these gray ones on, which are brand new, old stock that I had kicking around. I am going to call it a night. Tomorrow is Saturday. I want to get up early and try to hit some yard sales, if there are any. Thanks for watching. Have a good night.